Hello, my name is Jolene Rhodes, and in this lesson we are going to solve exponential equations algebraically. There are at least three methods to solve exponential equations, and we are going to actually look at three today. Method 1 does not work all the time. It's a very specific, it works in very specific cases, but in order to do method 1, the technique is to, what we're going to try to do is equate the bases. That means what we want is the base of each of our sides of our equation to be the same. For example, if I know that 2 to the x is equal to 16, what I could do is rewrite, because 16 is a power of 2, what I could do is rewrite 16 as 2 to the 4th power, because 2 to the 4th power is 16. And then once the base numbers are equal, so if the base numbers are equal and these two sides of our equations are equal, the exponents must also be equal. So what we're going to do is, knowing that the exponents must be equal, leads us to the fact that x must be equal to 4 if all we do is set our two exponents equal. Now, let's look at one that's slightly more detailed than this one. So let's look at example 2, where we have 3 to the 2x plus 1 power equal to 27. Now, if we look at solving 3 to the 2x plus 1 power equal to 27, once again, we can see that 27 can be written with a base of 3, because 27 is 3 to the 3rd power, because 3 times 3 times 3 is 27. Now, again, once the base numbers are the same, and these sides of our equations are equal, then that leads us to the fact that this exponent must be equal to that exponent. So this becomes a problem of solving 2x plus 1 equal to 3. In order to solve this, we'll subtract 1 from both sides, get 2x is equal to 2, divide both sides by 2, and our final answer here will be x equal to 1. A third example of this method could be used for, say, 8x equal to 16 to the 3x minus 1 power. Now, when we look at this problem, the 8 and the 16, I can't write 16 as a power of 8 or 8 as a power of 16. But 8 and 16 are both powers of 2. So let's write those as 2 raised to powers. So 8 is 2 cubed. 16 is 2 to the 4th power. We get this equation. Now, if you recall, when we raise a power to a power, we multiply our exponents. So this is actually equivalent to 2 to the 3x equal to 2 to the 12x minus 4 if we multiply our exponents together, distributing on the right-hand side. Now, again, the base numbers are the same, which leads us to the conclusion that the exponents must be the same. That leads us to the equation where 3x is equal to 12x minus 4. We want to solve for x. We're going to subtract 12x from both sides of our equation. We'll get negative 9x equal to negative 4. We'll divide both sides by negative 9. And we'll get a final answer then of x is equal to 4/9. Now this is a very specific method, and it can only be used when you can actually get the same bases on both sides of the equation. This is not a very common occurrence, but if it does happen, this method can be used as shown. Let's look at method 2. Okay, so in method 2, what we're going to do is simplify our equation so that we have just an exponential equation on one side exponential function on one side of the equation, then we're going to use the definition of a logarithm, and we're going to rewrite the equation as a logarithmic in terms of logarithms. And solve. Now, before you can do this, you might want to recall that the definition of a logarithm tells us that y is equal to the log base b of x if and only if b to the y power is equal to x. So this is what we're going to do. We're going to use this definition to rewrite our equations as logarithms and hopefully be able to solve the equation once it's written that way. Now, for example, let's look at 10 to the x equal to 231. Now, notice that unlike in the previous examples, we cannot write 231 as 10 raised to a power. So therefore, what we're going to do is rewrite this exponential function in terms of logarithms. If I do that using the definition above, what this says is log base 10 of 231 is equal to x. At this point, this is actually our answer. We do know that x is equal to the log base 10 of 231. If you would prefer a decimal, at this point you would need to use your calculator. On your calculator, log base 10 is the same as the log button on your calculator. So what we would do with this is, if we wanted to find the log base 10 of 231, is we would ask our calculator using that button, we would press log of 231, and we would ask our calculator what that number is, and if we do that, x equal to the log of 231 is actually equal to 2.364 approximately. Logarithms of most numbers are irrational numbers, which means they never end and they don't repeat. So the best we can do is to round off to 2 or 3 decimal places to get our final answer. Okay, let's try a second example. The second example is going to be 2e to the x plus 6 equal to 20. You should recall that e is an irrational number. It's a number like pi, so it's fixed. It's approximately 2.718, but we do use e. It's called the natural base, and do want to recall that, but we do want to solve for x in this problem. Now, what I said earlier is we did want to simplify our equations. We have just the exponential on one side of this equation, which means our first step to this is to subtract 6 from both sides. We want to get just the e to the x by itself. So we're going to just subtract 6 from both sides. We'll get 2 times e to the x equal to 14. We're then going to divide both sides by 2 so that I get just e to the x is equal to 7. Now once I have just the exponential on my left-hand side, what I'm going to do is rewrite it using logarithms. And if we rewrite it using logarithms, what we have is the log base e of 7 equal to x. Now, log base e, as I said, e is the natural base, and that is also a button on your calculator. It is called the natural log button. It looks like ln, and so we could actually find a decimal for this if we use the ln button on our calculator. So therefore, x equal to the natural log of 7, which is the same as the log base e of 7, is approximately 1.946, and that would be our approximate answer to this particular equation. Okay, let's try a third one. Okay, so let's look at 6 times 3 to the x plus 1 power equal to 24. Okay, now in order to solve this, again, you want just the exponential on the left-hand side of that equation. So the first thing we're going to do is we're going to divide both sides of our equation by 6. When we do that, we're going to get 3 to the x plus 1 power is equal to 4. The next step, remember, is to rewrite this in terms of logarithms. So this is the log base 3 of 4 equal to x plus 1. At this point, we do want to find the log base 3 of 4, or if that's all you want to do is solve for x, we could just subtract 1 from both sides. It is just, so our final answer, if we did that, we would get x is equal to the log base 3 of 4 minus 1. Now most people don't like to leave answers in terms of log base 3 of 4, so therefore we need to go find the log base 3 of 4. Some calculators can find logarithms of bases other than 10 and e. Other calculators cannot. So if yours can, you can go ahead and go find the log base 3 of 4. If not, then what we need is something called the change of base formula. Because what the change of base formula allows us to do is to change our problem from a base that perhaps we're not is not conducive to be able to find our answer to any other base that we want. If your calculator only has log base 10 and log base e, then of course the suggestion is to change from log base 3 to either log base 10 or log base e. The change of base formula says that if you have the log base b of x, you can rewrite this as the log base a, any base you want, of x, divided by the log base a of b, which was your original base. Now, as I said, if you're trying to use the change of base formula, usually we would change this to either log base 10 of x divided by log base 10 of b, or we could change this to the natural log of x divided by the natural log of b, because these two would be the ones that our calculator can find. So again, you can change to any base you want, but normally you would change to ones that your calculator can do. If we wanted to do this with this problem, what we could do is again change to a base that your calculator knows. Hypothetically, and again, it is your choice, so I'm going to change to base 10 on this example. If I did that, if I just look at this first piece, this log base 3 of 4, according to the change of base formula, that would be the log base 10 of 4 divided by the log base 10 of 3. Now, if we don't put a number down there at the bottom of the log, it is assumed to be a 10, but we'll put our 10 in there for neatness sake. So what we'll do is at this point, if you want a decimal, we'll go use our calculator, find the log base 10 of 4, divide by the log base 10 of 3, subtract that answer, subtract 1 from that answer, and we will get a final answer of 0.26. Okay, let's try one more before we go to method 3. Okay, so example number 4 is 5 times 2 to the x divided by 4 power plus 4 equal to 34. Again, we want to get the exponential by itself. So the first step to this would be to subtract 4 from both sides of our equation. We're going to have 5 times 2 to the x divided by 4 equal to 30. I'm going to divide both sides by 5 so I can get just that exponential by itself. We'll get 2 to the x divided by 4 power equal to 6. At this point, now that I have just the exponential, I want to rewrite this as a logarithm. If I rewrite it as a logarithm, I will get log base 2 of 6 equal to x divided by 4. Again, now then to solve for x, we would, since we've divided by 4, we're going to multiply both sides by 4, and we will get an answer of x is equal to 4 times the log base 2 of 6. Again, we don't normally leave our answers in terms of log bases other than 10 or e, or we go to decimals. So again, if your calculator can do log base 2 of 6, you would go ahead and do that at this point. If not, we'll use the change of base formula to change from log base 2 to either log base 10 or log base e. Since I used log base 10 on the previous example, I'm just going to use log base e on this one. So what we'll have is log base 2 of 6 is the same as the natural log of 6 divided by the natural log of 2. We'll go ahead and use our calculator, and when we use our calculator, this will give us an answer of 10.34. Okay, so that's method 2, and that just uses the definition of a logarithm, and it does use the change of base formula if needed, if your calculator cannot do logs of other bases. Method 3. Method 3, in order to use to solve exponential equations, is what we do is we're going to take logarithms of both sides of the equation once we get it simplified. Now, before we do an example of this, we do need to recall or note that properties of logarithms, one of the properties of a logarithm is that if I have the log base b of x to the power r, then what happens is the property of logarithm says that this can be rewritten or is equal to r, we can bring that exponent in front, times the log base b of x. And that's one of our properties of logarithms that you should already know, and we can use that then in this method to solve our equations. Let me give you an example. So, for example, if we have, say, 2 times 10 to the 2x plus 3 plus 7 equal to 15. I'll jump out there on this equation. Right now, if we want to solve this, the first thing you are going to do is the same thing that we did with the previous method, and that is get the exponential on the left by itself. So what I want to do is I'm going to subtract 7 from both sides of my equation. If I do that, I'm going to get 2 times 10 to the 2x plus 3 power equal to 8. Next step, we would divide both sides by 2. So I'll get 10 to the 2x plus 3 power equal to 4. At this point, what we're going to do then is actually use our method, which says we're going to take the logarithm of both sides of our equation. Now we can take the log base anything we want. So because the base of this particular exponential on the left-hand side is 10, I am going to take log base 10 of both sides of my equation. So I'm going to take the log base 10 of both sides of the equation. Now if we do that, we get log base 10 of 10 to the 2x plus 3 equal to the log base 10 of 4. Recalling our property of logarithms that we had above, we're going to, this exponent can be brought in front, so I'm going to get 2x plus 3 times the log base 10 of 10 equal to the log base 10 of 4. Log base 10 of 10, though, is 1, because 10 to the first power is 10. So our left-hand side just becomes 2x plus 3, and our right-hand side is the log base 10 of 4. If we want to solve for x, we're going to subtract 3 from both sides of our equation. And then we'll divide both sides of our equation by 2, which will give us x is equal to the log base 10 of 4 minus 3, that quantity all divided by 2. Again, if you'd like a decimal answer, we'll use our calculator, and this should give us a decimal answer of negative 1.199. Okay, let's look at a second example. For example, what if we have, say, 3e to the 2x equal to 24? Again, getting the exponential by itself, we're going to divide both sides by 3. We'll divide both sides by 3. We're going to get e to the 2x is equal to 8. At this point, once we have our exponential by itself, what I'm going to do is take logarithms of both sides of my equation. Because I do have base e in this problem, the best logarithm to take both sides is base e. So what I'm going to do is actually take the natural log of both sides of my equation. Take the natural log of both sides of our equation. We're going to have the natural log of e to the 2x equal to the natural log of 8. Again, property of logarithm, that brings the 2x. We can put our exponent in front. We'll get 2x times the natural log of e equal to the natural log of 8. Now the natural log of e, again, is 1 due to properties of logarithms, or the fact that e to the first power is equal to e. So this left-hand side becomes just 2x. Right-hand side is the natural log of 8. To solve for x, we're going to divide both sides by 2. So x is equal to the natural log of 8, all divided by 2, which in decimal form is approximately 1.04. Now, both of these had bases that were 10 or e, the ones that are built into our calculator nicely. What happens if not? So let's look at a third example. What if I just have, say, 4x equal to, 4 to the x power equal to 19? So now this one already has the exponential function just by itself on the left-hand side. So what I'm going to do is just take a logarithm of both sides of our equation. It does not matter in this case because it doesn't have a 10 or an e in it. We're going to use one of those because those are the built-in functions of our calculator. So we're going to use one of those. I'm going to take just log base 10 of both sides. Then again, does not matter. I'm going to take the common log of both sides. If you prefer natural logs, go right ahead. So what I'm going to do is take log base 10 of 4 to the x equal to log base 10 of 19. Using our property of logarithms, we're going to bring that x from our exponent and multiply it. So we'll get x times the log base 10 of 4 equal to the log base 10 of 19. Solving for x, we're just going to divide both sides by the log of 4. So x is equal to the log of 19 divided by the log of 4. Now, if you would like, take a second and do this problem the way we did in method 2, and notice that you will actually end up with exactly the same answer once you use the change of base formula. But if we're not happy again, if we want decimals, this decimal answer is approximately 2.124. Okay, I think we'll do one more example in this lesson. And so example 4 of method 3, let's do 3 times 1/2 to the x divided by 5 equal to 30. Again, we want to get the exponential by itself, so we're going to divide both sides by 3. I'll have 1/2 to the x divided by 5 equal to 10. Want to take logarithms at this point now that I have just the exponential on one side. I am this time, because I used log base 10 last time, we'll use log base e. So I'm going to take the natural log of both sides. So I'm going to get the natural log of this side of my equation equal to the natural log of that side of my equation. Properties of exponents, we're going to bring properties of logarithms, we're going to bring our exponent in front. So we'll get x divided by 5 times the natural log of 1/2 equal to the natural log of 10. Dividing both sides by the natural log of 1/2, we'll get x divided by 5 equal to the natural log of 10 divided by the natural log of 1/2. And last but not least, to solve for x, I want to multiply both sides of my equation by 5. So I'll get x is equal to 5 times the natural log of 10, all divided by the natural log of 1/2. And again, if you want to find out what that is approximately, using my calculator, negative 16.61. Hope this lesson has helped you solve equations of exponentials involving exponential functions, and thank you.